Smoke rolls over the Sicilian sky. Ash drifts like slow snow across the mountain's shoulder. Then, deep and thunderous, the earth exhales. Somewhere in the distance, a broadcast crackles through the static.
At the top of Europe's most active volcano today, the terrifying rumbling sound of explosions sent this tour group scrambling.
Her voice trembles for a moment before the wind swallows it. You can almost hear the footsteps, the panic against the roar. A guide shouts, "We're 2 steps away."
The mushroom cloud behind them ballooning above Sicily's highest peak. The column of smoke shooting more than 20,000 feet in the air.
The echo fades, leaving only the low growl of the mountain. For a heartbeat, the world holds its breath. The footage lasted seconds, but what it captured was more than an eruption. It was a warning. For centuries, Mount Etna has breathed fire, ash, and myth, rising, collapsing, and rising again. But the newest fear isn't what burst from its summit. It's what moves beneath its feet. Scientists tracking the mountain's flanks now see a pattern the naked eye can't. Etna isn't just erupting, it's sliding. Millimeter by millimeter, season by season, a whole side of the volcano drifts toward the Ionian Sea. Most days that motion is silent, harmless, forgettable, until the day it isn't. Because when a mountain leans into water, the sea does not simply receive it. It answers, fast, heavy, and without mercy. This is the story of a living volcano and the ocean that made it. A slow, relentless movement carrying the weight of an unthinkable future. If the flank goes suddenly, the first wave will not be a metaphor. It will be a wall, and the Mediterranean will feel it long before the ash has time to fall. From the air, Sicily glows. A triangle of light surrounded by blue. And rising above it all, dark and restless, is Mount Etna. A mountain that never sleeps. Its slopes are streaked with ancient lava, vineyards, and roads that vanish into mist. Towns cling to its flanks, trusting the same soil that once buried others. To the locals, Etna is both neighbor and deity. They call her Mama Etna, a protector, a destroyer, a living pulse in stone. But what looks eternal is, in truth, fragile. Etna stands where 2 worlds collide, where the African plate slides beneath the Eurasian plate. Beneath the Mediterranean, that collision melts the edge of the oceanic crust, turning rock to liquid fire. Every drop of magma that rises through Sicily's crust is born from that slow-motion subduction, an ocean disappearing beneath a continent. That's why Etna exists at all. It isn't just an island volcano. It's a mountain built by the sea, a monument to the violence beneath the Ionian Sea's calm surface. Every eruption adds a new layer, each one heavier than the last. Ash hardens into basalt, and basalt fractures under its own weight. Slowly, the eastern slope begins to tilt, inching seaward, carried by the weak sediments below. To the eye, the mountain looks unchanged, but deep underfoot, tension builds like a held breath. 1,000 tiny movements, invisible yet cumulative, quietly nudge the volcano toward the Mediterranean abyss. Scientists studying satellite images describe it as a living mountain on the edge of balance. Because one side of Etna is anchored to the land, and the other is already halfway to the sea. And while its eruptions draw the cameras, its slow descent draws the scientists. Something ancient is stirring, not in the crater above, but in the ground below. In 2018, a group of scientists from the German Research Center for Geosciences joined Italian volcanologists from INGV Catania. Their goal was simple: to listen to Etna in ways no human ear could. They placed instruments across the mountain, but also beneath the sea. On the dark seafloor, anchored to cables, were sensors designed to track the unthinkable, the movement of an entire volcano. Weeks passed, then months. At first, the data showed little more than tremors. The mountain breathing, as it always had. Then, 1 week in May, the numbers changed. Across just 8 days, the southeastern flank of Mount Etna, a mass of rock the size of a city, moved 4 centimeters toward the Ionian Sea. 4 centimeters, tiny to us, massive to geology. For the first time in recorded history, scientists had captured the actual movement of Etna's body sliding downhill, not from lava pressure, but from gravity and the slippery clay layers below. To the researchers, it was both a revelation and a warning. Etna wasn't only erupting upward, it was collapsing outward. That 2018 reading became a cornerstone discovery, proving that Etna's base was creeping toward the sea like a glacier of stone. Slow, predictable, until it isn't. The more scientists mapped it, the clearer the danger became. Beneath the volcano, a deep fault, long hidden under centuries of lava, acts as a hinge between stability and collapse. If that hinge gives way, the mountain's entire eastern flank could shear off and plunge into the Mediterranean below. In the quiet of their laboratories, surrounded by seismographs and satellite maps, one truth began to form. Etna is not standing still. It's drifting, and it has been doing so for decades. The question now isn't if it moves, but how far it will go before the sea finally takes it. Beneath the blue calm of the Ionian Sea lies a restless world, a network of fractures, faults, and buried scars where the African plate is slowly sinking into the mantle beneath Europe. This is the engine that feeds Mount Etna. Every tremor, every eruption, every spark of molten rock begins here, in darkness, miles below the waves. When that oceanic crust descends, it drags with it cold seawater and soft sediments. Those layers melt, releasing fluids that rise like ghosts through the crust, weakening everything they touch. And above that unstable foundation sits Etna, heavy, active, alive. It is a mountain perched on Greece. Each eruption adds new weight. Each rainfall seeps into cracks, lubricating faults that already lean seaward. Over time, the volcano doesn't just grow, it slides. The mushroom cloud behind them ballooning above Sicily's highest peak. The reporter's words echo faintly, not as breaking news now, but as memory. A reminder that what we see above is only half the story. For every eruption that lights the sky, there's an invisible one below. Tectonic plates grinding, slipping, and bending the seabed itself. Geologists have mapped that seafloor with sonar. What they found isn't solid rock, but a mosaic of fractures running parallel to Etna's slope, each one a potential escape route for the mountain's flank. To the untrained eye, the Ionian Sea seems peaceful, but to those who study it, it's an extension of Etna itself, a liquid mirror reflecting the same instability. Somewhere beneath those waves, pressure builds quietly, year after year, and scientists warn, when the ocean moves, it moves everything resting above it. If Etna is the visible face of the Mediterranean's power, the Ionian Deep is its unseen hand, slowly, patiently, pulling the mountain home separate. Every mountain has a breaking point. For Etna, scientists believe it lies somewhere deep within that eastern flank, the side already inching toward the Mediterranean. On paper, the movement looks small, millimeters a year. But when you're dealing with billions of tons of rock, a millimeter is momentum. And momentum, once it finds release, is irreversible. Computer models from the Helmholtz Center for Geosciences and Italy's INGV simulate what would happen if that flank suddenly gave way. The results are sobering. A single fault rupture could send up to 5 cubic kilometers of volcanic rock crashing into the Ionian Sea in minutes. That kind of displacement would hurl a massive wall of the water outward, striking the Sicilian coast first, then radiating across the Mediterranean. The wave would travel fast, hundreds of kilometers per hour, reaching the shores of Malta, Greece, and North Africa within an hour. Harbors that have stood for millennia could vanish under walls of water taller than the buildings around them. And yet, this isn't just a disaster movie scenario. It's a real geological possibility, one written into the history of this planet. Because Etna wouldn't be the first to fall. Across the world, other volcanic giants have suffered the same fate. In the Canary Islands, ancient slopes collapsed into the Atlantic, carving scars still visible from space. In Hawaii, similar slides created waves that reshaped entire coastlines. Even the Mediterranean bears the marks of past collapses, now buried beneath the seafloor like forgotten catastrophes. Etna's story fits the same pattern, only closer and still unfolding. Scientists don't speak in headlines. They speak in probabilities, in time scales that stretch far beyond human memory. And yet, when asked if Etna's collapse is possible, their answer is unsettlingly clear. Yes. The only uncertainty is when. In the calm of the present, that answer feels distant. But geologic time doesn't care for calendars. It builds quietly, then releases suddenly, without warning, without pause. When that day comes, Etna won't roar like it does during eruptions. It will lurch. The sea will rise to meet it. And the Mediterranean, once calm and blue, will remember how to be violent again. Every movement is measured now. More than 100 seismometers surround Etna like a stethoscope pressed to the earth. They listen. Every second, every tremor, every sigh. Above ground, satellites trace the volcano's pulse from orbit, detecting subtle bulges in its slopes. Drones hover near the craters, capturing heat and gas plumes that tell stories invisible to the eye. Each eruption is a release of lava, of pressure, of data. Inside laboratories in Catania and Berlin, those signals become patterns, lines that rise and fall like heartbeats. Every pulse tells scientists the same thing. Etna is alive and it is moving. For the people who live on her flanks, that life is simply part of their own. Children walk to school across roads dusted with ash. Farmers harvest vineyards nourished by the same minerals that destroyed their grandparents' fields. Every generation rebuilds, as if rehearsing for the next eruption. They call her Mama Etna with a kind of reverent defiance, a name that mixes affection and fear. When darkness falls, they can see her glow from miles away. A soft orange pulse over rooftops and vineyards. It's a strange comfort, a mountain that never truly sleeps. In every flicker of light, they read her mood, the way sailors once read the stars. The people of Sicily don't just live near Etna. They live with her, listening for the smallest tremor, feeling her warmth on the wind. It's a relationship built on instinct and surrender. Because when the ground itself becomes family, you stop asking for promises and start learning how to stay. She gives them fertile soil, but takes what she wants in return. To them, she's not a threat, but a truth. Yet scientists watching her movements see a different kind of rhythm. One too large to fit inside a lifetime. They know that what appears peaceful on the surface is tension below, and what looks like stability is just balance in slow motion. Still, there's awe in their work, and understanding that studying Etna is like studying time itself, because in every shift of the mountain's flank, in every quiet tremor, the planet is speaking, reminding us how alive it really is. If stories like this inspire you, make sure to subscribe. Every week we uncover the real stories buried beneath the sea and time itself. And as the data continues to stream in, from craters, from satellites, from sensors lying silent on the seafloor, a new pattern begins to emerge. The sea itself isn't still, it's moving too. And in ways no one fully understands, it's pulling the mountain down with it. Far beneath the surface, the Mediterranean is not still. It shifts and breathes, folding under the weight of continents. On the seafloor east of Sicily, the Ionian Plate bends downward into the Earth's mantle. A slow, quiet motion that shapes everything above it. This is where Etna's foundation meets the ocean's force. Every quake, every pulse beneath the Ionian Sea reverberates upward into the mountain's core. To most of us, it's imperceptible. To Etna, it's a constant tug, an invitation to fall. Oceanographers mapping the seabed with sonar have found scars carved into the slope below Etna's flank. Ancient landslides long buried by sediment. Each one marks a moment when part of the island gave in to gravity and slipped into the sea. And they all share a pattern, the same direction, the same slow drift, the same story repeating through time. Some of those scars trace back tens of thousands of years to when sea levels were lower and coastlines different. Others are younger, evidence of smaller slides that may have sent silent ripples across the Mediterranean. No one on the surface noticed, but the ocean remembers. As pressure builds deep in the subduction zone, it doesn't just bend the crust, it bends time. Each millimeter of motion stacks upon the next until the system resets itself with violence. The scientists call it tectonic feedback, the invisible dialogue between sea and stone. One moves, the other responds, and together they write the next chapter of the Mediterranean story. Etna is only the visible half of that story. The rest lies in darkness, in the cold, crushing pressure of the Ionian Deep. Down there, silence is not peace. It's the sound of waiting. We like to believe the land beneath us is permanent, that mountains stay where we leave them, and coastlines will wait for us to return. But the earth has never been still. It only moves at a pace too patient for our eyes. Mount Etna is a reminder of that truth, a slow revelation carved in fire and stone. Every eruption, every fracture, every shift toward the sea is part of a single conversation between land and water. Long before history, this same process built Sicily from the seafloor. Now, piece by piece, it's giving it back. Scientists can measure the movement, model the risks, even predict the pattern of collapse. But they can't stop what's written into the planet's design, because the same forces that destroy also create. The same magma that burns a village will one day form new ground beneath another. In the grand timeline of the Earth, collapse is not the end. It's a beginning wearing a different shape. Etna's slow descent into the Mediterranean isn't a failure of nature. It's nature returning to balance, the ocean reclaiming what it gave, and somewhere in that motion lies a strange kind of peace. The knowledge that we, too, are part of a world always becoming something new. If this journey moved you, subscribe to Tectonic Ocean, where the planet's story is still being written, one eruption at a time, because even the mightiest mountains eventually return to the sea.